Unit 3-4 is the angles of a triangle. Angles of a triangle. Our little symbol for triangle is a triangle. Now, geometry definitions tell you actually how to draw the thing it is you're defining. By definition, a triangle is a figure formed by three segments joining three non-collinear points. Example, if we wanted to create a triangle, we would begin with three non-collinear points. And then we would draw the segments that join them. Bing, bing, bing. The result is a triangle, a figure formed by three segments joining three non-collinear points. The three segments are called the sides. So the sides are segment AC, segment AB, and segment BC. On a prism, those are called edges. The three non-collinear points are called vertices. So the vertices are points. Point A, remember we name a point by a capital letter. Point B and point C. So a triangle is a figure formed by three segments joining three non-collinear points. The three segments are called the sides. The three non-collinear points are called the vertices. You can name a triangle or any other polygon starting at one vertex and going clockwise or counterclockwise in either directions. So we could start at A and say triangle ABC. We could start at A and go the other way, triangle ACB. We could start at B and say BAC, or we could say BCA, or we could say CAB, or we could say CBA. So there's 6 different ways that we could have named that triangle. Okay? 6 different ways. Okay? Now we're going to classify triangles according to the lengths of their sides and the measures of their angles. A scalene triangle is a triangle that has no equal sides. Couple of examples, 3, 4, 5, 5, 7, 14. An isosceles triangle that might remind you of an icicle hanging off of a roof. Might not, but it might. Isosceles triangle. An isosceles triangle is a triangle that has at least, that's an important part of this, at least 2 equal sides. Normally, when we think of an isosceles triangle, we think of a triangle with 2 equal sides. In an isosceles triangle, the 2 equal sides are called the legs, and the third side is called the base. It could be, though, that all three sides are equal because the definition says at least. So this triangle is really isosceles 3 times over. It's isosceles with those legs and this base. It could be isosceles with these legs and this base. It could be isosceles with these legs and this base. So an equilateral triangle is sort of like having 3 isosceles triangle situations in one, you see. So isosceles triangle is a triangle that has at least 2 equal sides. Equilateral comes from the 2 words equal and lateral means side or sides, and so we have equal laterals or equal sides, you see. And so in an equilateral triangle, all sides are equal, or it has 3 equal sides. That's classifying triangles according to the lengths of their sides. Now we will classify triangles according to their angle measures. An acute triangle is a triangle where, excuse me, where all the angles are less than 90 degrees. In other words, it has all acute angles. An obtuse triangle is a triangle that has one angle greater than one angle greater than 90 degrees, or one obtuse angle. And here's some examples. This has one angle more than 90, 150 degrees. That has one angle more than 90, 110 degrees. An obtuse triangle has one obtuse angle or one angle greater than 90 degrees. A right triangle has one angle that is 90 degrees. In other words, it has one right angle. And there's some examples. Equiangular, there's 2 words too. Equa and angular, in other words, equal angles. All 3 angles are equal. All 3 angles are equal. Any questions on that? We learned in Algebra 1, and we could do some proofs of this in geometry, and we're not proving everything in 2-column proof form in geometry. We're actually discovering it with a compass and a protractor and a ruler. Although we could do 2-column proofs of anything that says theorem. We learned in our discovery, and we already knew it from junior high in Algebra 1, that the sum of the angles of a triangle is 180 degrees. In this particular triangle, we could find the missing angle because we know that the sum of all 3 is 180. So we could say x plus 50 plus 70 is equal to 180 degrees. And then we could solve for x. Now remember the order of operations horseshoe. We're going to do anything we can to simplify in the order. Please excuse my adherent Sally. looking for distributive property and combining like terms, and what we find that we can do is combine like terms. So x plus 120 is equal to 180. There's nothing else we can do to simplify. The variable is not on both sides, so it is time to undo. So we're going to undo addition by subtraction, and we'll get x is equal to 60 degrees. Okay? In the next example, the little box tells us that that angle is 90 degrees. So we can say that x plus 20 degrees plus 90 degrees is equal to 180 degrees, because the sum of the angles of a triangle is 180. We now can combine like terms and get that x plus 110 degrees, x plus 110 degrees is equal to 180 degrees. We're going to now undo addition by subtraction, and we get x is equal to 70 degrees. Any questions on theorem 7? It's theorem 311. The sum of the angles of a triangle is 180. And then we have some corollaries under theorem 311. Corollary 1. Now this is a rule. It's like a theorem, but it can be quickly deduced, proven, logically figured out from a theorem, so we call it a corollary of the theorem. If two angles of one triangle equal two angles of another, then the third angles are equal. So if this is 50 and 60, and that is 50 and 60, then angle 1 and 2 have to be the same, because they're what's left over out of 180 for both of them. And what's left out of 180 for both of them would be 70, which we could prove mathematically that the resulting angles would have to be the same. Each angle of an equal angular triangle is 60 degrees. Now we can reach this conclusion because if all of the angles are equal, we call it equal angular. The sum of all of them is 180 degrees. When we combine like terms, we get x plus x plus x, which is 3x, is equal to 180 degrees. We could solve for x by undoing multiplication by division and get that x is equal to 60. And so we reach the conclusion that each angle of an equal angular triangle is 60 degrees. And there we can see why it's a corollary. We can use a little bit of algebra, use a little bit of mathematics, and quickly prove this based on the fact that the sum of the angles of a triangle is 180 degrees. We can quickly prove also that the acute angles of a right triangle are complementary. And remember that complementary angles are two angles whose measures have the sum of 90. So in this diagram, angle x and y plus the right angle, which is 90, would have to add up to 180. X and y are acute angles. So we would say that these are the acute angles of this right triangle. And we want to prove that those acute angles are complementary, which means that they add up to 90 degrees. Well, if we take the 90 degrees off of this side and take it off of that side, the result would be that x plus y is equal to 90 degrees. And so again, we've quickly, with a little bit of algebra, proven that the acute angles of a right triangle are complementary, given that the sum of the angles of a triangle is 180 degrees. And then we have corollary 4, which says that there can be at most only one right angle or one obtuse angle in a triangle. If a triangle adds up to 180 and you have one a right angle that's 90, 180 minus 90 is 90. That means that you have the two angles left that have to add up to 90. So you can't have two that are 90. You wouldn't end up with a third angle. You couldn't have a triangle, you see. And the same way, if you have one angle more than 90, if you had a second angle more than 90, you wouldn't end up with a triangle. So since the sum of the angles of a triangle is 180, that tells us that we can't have two angles that are 90 apiece, because that makes the 180 without getting the third angle in there, and making them both obtuse would make it even worse. So we've classified triangles according to the lengths of their sides and the measures of their angles. We said a triangle is a figure formed by two rays with a common endpoint. The two rays are called the sides. The common endpoint is called the vertex. A scalene triangle is a triangle with no equal sides. An isosceles triangle is a triangle with at least two equal sides. A right triangle is a triangle with all three sides. I'm sorry, an equilateral triangle is a triangle with all three sides equal. An acute triangle is a triangle with all angles less than 90 degrees, or all acute angles. An obtuse triangle is a triangle with one obtuse angle, or one angle more than 90 degrees. A right triangle is a triangle with one right angle, or one angle more than, or one angle that is 90 degrees. We learned that the sum of the angles of a triangle is 180 degrees. And we learned some corollaries in that if two angles of one triangle equal two angles of another, then the third angles are equal. We learned that the acute angles of a right triangle are complementary. We learned that each angle of an equal angular triangle is 60 degrees. And we learned that there can be at most one right angle or one obtuse angle in a triangle. I believe, in summary, I may have left off the fact that an equal angular triangle is a triangle that has all equal angles. Okay? And then we have this last one, which we wanted to kind of focus on because it's one that seems to slip our mind as we move from this to lessons in the future for some reason. An exterior angle is equal to the sum of its two remote interior angles. Now, if I were to draw a triangle, then the angles inside that triangle are called interior angles. They're the angles inside of it. Well, if I extend one side of a triangle, the angle formed when I extend that side is called an exterior angle. An exterior angle, which is actually the angle that I'm really highlighting there. So I'm going to turn this back green. An exterior angle is equal to the sum of its two remote interior angles. Remote means far away. So the two interior angles most remote from that exterior angle is those two. And so that exterior angles is equal to the sum of these two remote interior angles. So what we want to do in the next picture is identify what the remote interior angles are that go with a certain exterior angle. So here's exterior angle 1. Thinking about the interior angles of this triangle, 2, 3, and 6, we would want to think, which ones are most remote? Well, the vertex of angle 1 is here. And when we think about what is remote, we want to think about what is not adjacent. Remember that adjacent angles are two angles in the same plane with a common vertex, a common side, and no common interior points. The interior angle, angle 2, is adjacent to angle 1. The ones not adjacent to angle 1 are interior angles 3 and 6, and so we say they are remote from angle 1. According to this theorem, then the exterior angle, angle 1, is equal to the sum of its two remote interior angles, angle 3 and angle 6. Okay. Now we're going to draw remote angle, angle 4. We're going to identify its two remote interior angles. Again, here's the triangle. The interior angles of the triangle are 2, 3, and 6. The one adjacent to angle 4 is the one that has the same vertex and a common side with angle 4, which is angle 3, meaning that the other two, 2 and 6, are the ones that are remote. And so we know that angle 4 is equal to the sum of its two remote interior angles, angle 2 and angle 6. Likewise, we could draw exterior angle 5. The interior angles again are the angles inside the triangle 2, 3, and 6. We want the ones remote from angle 5, which are the ones that are not adjacent. Adjacent to angle 5 is angle 6 because they have a common vertex, common side, they're coplanar, and they have no common interior points. The ones not adjacent to 5 that are interior are 2 and 3, so those must be the ones remote from angle 5. So angle 5 is equal to angle 2 plus angle 3. An exterior angle is equal to the sum of its two remote interior angles. So this exterior angle x degrees is equal to the sum of its two remote interior angles. So x degrees is equal to 110 degrees plus 10 degrees, which is equal to 120 degrees. Any questions on that? An exterior angle is equal to the sum of its two remote interior angles. And so that brings us to daily work 3-4, which will be in the next recording.